All right, so this is going to deal with properties of logarithms. That's an O. All right, so I'm going to list some properties. So the first property we call the product rule of logarithms. All right, so the product rule of logarithms tells me that if I have a product of a log, such as log of x times y, we can rewrite that as a sum of logs, a log x plus log y. So basically, they're just telling us that that logarithm sort of distributes through. And if you think about exponent rules, because really logarithms are exponents, and when you multiplied variables, you added those exponents. So that's basically what this rule is telling us. Second one we go with, I'm going to use the product rule of logarithms. So the product rule tells me if I got a log of x raised to the y exponent, this is sort of like when you have an exponent raised to an exponent, what we do is bring the y down to the front and multiply by the log x. Okay, so when you got a log of a variable or number with an exponent, you bring the exponent down to the front and write it as a product. All right, I got a quotient rule of logs. So the quotient rule would be taking a log of something being divided. And you ought to rewrite that. If you remember, when you divided those variables, you subtracted the exponents. So the quotient rule of logarithms follows that, and we write it as a difference of logs. And it's always the top minus the bottom on these, okay? And then I always write this just to keep y'all up to date. But anytime you take a log and the base matches that result, anytime that base matches that result, you're going to get a 1. And y'all, I'm going to try to, let me explain what these logs are because I wasn't able to be with y'all yesterday. So I just want to go over a little bit with you about what a log is, okay? So yesterday y'all had problems like this, log base 2 of 8. So I just want y'all to realize that a logarithm finds an exponent. It finds the exponent that 2 was raised to turn it into an 8. So what you want to know is how many times would you multiply 2 times itself to get 8? And that would come out as a 3. Now I can't remember if my video I sent y'all yesterday, it had some of 9.5 on it. I don't remember if it had anything on there actually working these on the calculator. So I want to show y'all how I could find log base 2 of 8 on my calculator. So to do that, I would hit the math button. And on the math button, you would arrow straight down until you found something that said log base. If you hit enter on log base, it brings it on the screen. And then all you got to do is put in the 2 and then arrow over and put in the 8. And the calculator will now find the exponent of 3. So I'll get y'all good on that calculator stuff, okay? So let me work problems dealing with these properties and show y'all what they're going to hit us with. So my first example, I'm going to express as a sum of logarithms. All right, so this will be number 1. They're giving me log base 6 of 6 times 36. Now, they don't want me to work it or anything. They just want me to rewrite this as a sum. So what I would do is I'd distribute my log 6 to both of these. So I get a log base 6 of 6. And then remember, since these are being multiplied, we rewrite them as a sum. And then you distribute the log base 6 to the 36. Now you could go further, but they just wanted me to rewrite that, and that was it. So a lot of these in this section, you're just rewriting to change them, okay? So now we got an ln of an x times y. And y'all, ln, it's even on the calculator. It's a special logarithm, but ln is really a log base e, okay? ln stands for natural log. And if you're in business classes, you'll play with this ln a lot more, okay? But all we want to do is rewrite this product as a sum. So I'm going to distribute the ln to both of these. So I get a ln of x plus ln of y. Now, y'all, when you punch this in MyLabs Plus or MyMathLab, that's a little L, not a capital I. So it messes up a lot of people because they put a capital I in on these answers, and it's actually a little L in. When you write it in MathLab, it'll make it bold when you write it right, okay? All right, next you're going to express as a product. And this will go with my second little property I gave you. This one has log base 10 of y to the 16th. And remember, to express it as a product, since this variable has an exponent, we basically got to move that exponent down to the front and rewrite it as multiplication, so that this gives me 16 times log base 10 of a y. Oh, so that would have been number 3, y'all. And then this one will be number 4. All right, ln of the 5th root of a 3. So what we got to be able to do is turn this radical into an exponent. So let me refresh y'all on radicals. So to rewrite a radical as a fractional exponent, you take what was under that radical, a, and then we're going to rewrite the radical as an exponent. And it's always the exponent of x over the root of the radical, which is a y. So to rewrite something from a radical to a fractional exponent, just remember that the root of the radical is the bottom number on the fraction. Now, if the a didn't have an exponent by it, you would automatically make that top a 1, okay? So I'm going to rewrite this one so that I get an ln of 3. We're going to rewrite the fifth root radical. Remember, the root goes to the bottom, so the 5 will be on bottom. Since the 3 don't have an exponent by it, I would treat that like a 1 so that it turns into a 1/5. So now I've got my exponent. I'm going to move that down to the front so that I get a 1/5 times ln of 3. So y'all just remember, if you got a radical, turn it into a fractional exponent and then work the problem, okay? So if you notice what we're doing, we're giving you one with logs and one with natural logs on every one of these problems. So now this one they want me to express as a difference of logs. So to end up as a difference, it's going to start out as a division. So we got log base c of d over 7. All right, remember we said on our property, it's always the top minus the bottom, but you got to distribute that log c so that you get a log base c of d minus a log base c of 7. And always try to remember these by what I was doing with the actual variables. When I was dividing variables, I subtracted the exponents. Up here, when I multiplied variables, I added exponents. So they sort of follow those exponent rules, okay? All right, y'all, and then this one has ln of v over w. And also, when you're writing these in, if they use capital letters, you got to use capital letters on those answers, okay? So capital letters and small letters. All right, so this one will be distribute to ln. So you get an ln of v minus the bottom, which will be a ln of w. All right, so that page not too bad, but then they start turning it up a little bit. And this one they say rewrite as sums or differences. So I got a log base b of x to the 3rd times y to the 6th times z. So these are being multiplied, so we know when we rewrite this, it's going to be sums. All right? So I distribute the log b to everybody, so I get a log base b of x to the 3rd plus log base b of y to the 6th plus log base b of z. So you take all the factors. So since you had 3 factors in here, you had to have 3 logs down here. Now, I've rewritten it as a bunch of sums, but y'all, there's one more thing I got to do to these. These parts where you got the exponents, we got to bring the exponents down in front and rewrite those as products. So this 3 is going to go to the front, and that 6 will go to the front of its log. The z didn't have an exponent, so we're good with it. So this one would become 3 times log b of x. This one would be 6 times the log b of y. At the end would be my log b of z. So when you rewrite these as sums or differences, if they got exponents, we got to bring those exponents down, okay? And then nothing else we can do to that, so we move on to number 8. All right, this one will have log base b. On the top, I got p to the 3rd, q to the 7th. On the bottom, I got m to the 5th, b to the 7th. So when you rewrite this as sums or differences, if it's on top, it'll be positive. If it's on bottom, it'll be negative. So top factors are positive. Bottom factors are negative. So when I rewrite this, I'm going to distribute that log b to all 4 factors. So I get a log b of p to the 3rd. Since the q's on top is going to be positive, so that'll be plus a log b of q to the 7th. The m and the b are on bottom of the fraction, so they're going to be negative. So it'll be minus log b of m to the 5th minus my log b of b to the 7th. So I distributed my log to all 4 of these, and when I rewrote it, if it was on top, they were positive, bottom, they were negative. Now, if you notice, all 4 of these have exponents, so all these exponents got to be brought down to the front of those logs. So this one would give me a 3 log b of p, plus this one I would get a 7 times a log b of q. And y'all, I'll tell you what, these problems sort of stay big with a lot of stuff in them because we really can't add like terms and combine any of these, okay? All right, so this one will give me what? 5 times the log b of m minus 7 times the log b of b. Now, I'm going to tell you what, this problem can go one more step. And it's because of that log b of b. Log b of b, and if you remember, I gave you them properties a while ago up here. And I had this one that said log a of a equals 1. When that base match that result, you get a 1. Well, y'all look at this. You got a log b of b. So the log b of b part equals 1. So since this part equals 1, 1 times 7 is just going to make that part equal a 7. So I'm going to get 3 log b of p plus 7 log b of q minus 5 log b of m minus 7. So you got to watch these. If you get a log of a base that matches that result, you got to make that into a 1. Okay. And then let's see, nothing else we can do to that. So that would be our final answer. All right, so y'all good on that? All right, so you know we're going to do one for ln next. This one has ln of 6 divided by 7x to the 7th y. And I think that video I sent last night, I think it stopped on that number 8. So this would have been where the new stuff would have picked up if you was on that video.
It did.
Mm-hmm. So on this one, I'm going to distribute my ln to everybody. And once again, if they're on top, they're going to be positive. If they're on bottom, they're going to be negative. And y'all treat that bottom like 3 different factors. You got a 7 sitting here, an x to the 7th, and a y. So this will be the top positive, ln 6, minus ln 7 on the bottom, minus ln of x to the 7th on the bottom, and then minus ln of the y. So the trick on this one was just to realize there was 3 factors down here. And y'all, I got one more step on this whole problem. And that is to turn that 7 and rewrite that as a product. So I got my ln 6 minus my ln 7 minus, this one now gives me 7 times ln of x, and then minus my ln of y. So some of these ain't too bad. You just gotta keep up with, is it on top and positive or on bottom and negative on those, okay? Now I'm not gonna lie, this number 10 is a little tricky. I got log of a square root c to the 9th times a d. So remember, it's in a radical, and that radical has all this underneath it. So when I rewrite it with my radical, I'm going to put the C9D in parentheses. I'm just wondering what to make that exponent. So since all this is inside, you would treat the top exponent like a 1, because it'd be like all this is in a parentheses, okay? The bottom exponent, there's not a number there for my index on my radical. Anytime there's not a number there, it's automatically a 2. So a radical by itself just does the square roots, okay? So now watch what I'm going to do. If you remember exponent rules, when you got variables inside parentheses raised to exponents, you distribute that exponent through the parentheses and multiply. So the C has 9 times 1/2, which is a 9/2. The D, no exponent there, so it's like a 1, and 1 times 1/2 is 1/2. All right, these are being multiplied, so I rewrite that as a sum. I got a log C of 9/2 plus a log D to the 1/2. And y'all, just like before, my last move is to take these exponents and rewrite those as a product, so that this one gives me 9/2 log C, plus this one I distribute to 1/2, and I get a 1/2 log D. All right, no more exponents to worry about, so that'd be our final answer. Oh, I got a big one coming up, so I'm going to turn over the page for this next one, okay? All right, y'all, so let me bring number 11 over here because this got a big radical. I got a log base C. My radical is a fourth root. On top is a M16 N20. On bottom is a C5 A5. So definitely the first thing I'm going to do is get rid of this radical. I'll put everything in parentheses, M16 N20 over C5 A5. And since this was a fourth root, this exponent will be a 1 over 4. So radicals are always 1 over whatever that index is, okay? Now, what I'm going to do is distribute that exponent to all 4 of these factors. So the M, 16 times 1/4. So if you multiply that out, 16 times 1/4 would give you a 4. Then you got N, 20 times 1/4 would be 5. So remember, I'm just doing 20 times 1/4 is 20 over 4, which give me 5. Okay. On the bottom, 5 times 1/4 is just going to be 5/4. So that gives me C to the 5/4. And then the A, since it's got a 5 also, will be 5/4. And remember, all those can be done on here. 16 times 1 divided by 4 will give me the 4, and so on, okay? But y'all, all I did to that whole problem so far was get rid of that radical. Now, we're going to rewrite it. If it's on top, it's positive. If it's on bottom, it's going to be negative. And distribute the log C to all 4 of those. So I get a log C of M to the 4th plus a log C of N to the 5th. The bottoms are going to be subtracted, log C of C to the 5/4 minus log C of A to the 5/4. So I've distributed my log and got it rewritten positive and negative. And guess what? Next, we're going to bring all these exponents down to the front. So this will give me 4 times log C of M. This one will give me 5 times log C of N minus 5/4 log C of C minus 5/4 times log C of A. And y'all, it looks like I've got one more thing on this one to do because I've got a log C of C sitting here. And remember, log base C of C equals 1. So since this equals 1, 1 times a negative 5/4 is just going to be a negative 5/4. So notice, I got to rewrite all that just to change that. So here we go. I got a 4 log C of M plus 5 log C of N minus 5/4 minus my 5/4 log C of A. Okay, so just remember, anytime you get one of these and that log base matches that result, you got to change that into a 1. So I'll write that right here. That equals 1 on that part, okay? So y'all, that is pretty wild there. All right, so now we're going to go the other way and express as a single logarithm. So we took a single logarithm and rewrote it as products and sums. Now we're going to take products and sums and turn them into a single log. So 12, I got log base C of 22 plus log base C of 45. All right, so what I would do, since they're being added, I would rewrite this as multiplication. So I would have log base C of 22 times 45. And y'all, I can even go further on this one because I know what 22 times 45 is. I can multiply that on the calculator. And 22 times 45 gives me log base C of 990. All right, so that's all they wanted on that. So we go to number 13. So 13 says express as single log. If possible, simplify. And y'all, I'm pretty sure that it's going to simplify because they wouldn't write that on this problem if it didn't. So look what we got. We got a log of 1,000 minus a log of 100. So remember, since this is being subtracted, when you rewrite this, it's going to look like division. So addition rewrites as multiplication, subtraction rewrites as division, so that we get a 1,000 divided by 100. Well, I can simplify that because 1,000 divided by 100 is 10. And y'all remember this, anytime a log does not have a number here, it's automatically assumed to be a 10. So what does log base 10 of 10 equal? Well, y'all, you got a log on front of that calculator. So log of 10 equals 1. And we knew that because that base matches that result. So the final answer on that would be a 1. All right, what's next? Number 14, and it says the same thing, y'all. Express as a single log. If possible, simplify. So I got a 1/4 log C of x plus 5 log C of y minus 4 log C of x. So if the last thing I did before was bringing down these exponents, the first thing I do going the other way is bring those exponents up. So the first thing we'll do, bring the exponents up. So this gives me a log C of x to the 1/4 plus log C of y minus log C of x to the 4th. Now, we've rewritten them with the exponents up. Now, remember, if they're positive, they're going to be on top. If they're negative, they're going to be on bottom of my fraction. So I'm going to bring out that log C. On top, I got an x to the 1/4 and a y. On bottom, I got the x to the 4th.
Shouldn't it be log cy to the fifth?
Say again.
Shouldn't it be log cy to the fifth?
Oh, hold on. I didn't put my 5 right here, did I? Okay, there you go.
Yeah.
Yeah, see on that second step, I didn't bring my 5 down. I think I said it, but I kept on going. So yeah, y'all put a 5 on that, and then bring that 5 down here. Now, y'all, the only other thing you can do to this problem, we cannot leave a fraction with x's on top and x's on the bottom. So to simplify that, the variable will end where the larger exponent was. So since the 4 is the larger exponent, the exponent will be on the bottom, and I'm going to take 4 and subtract 1/4 from it. So 4 minus 1/4 is going to give me 3 3/4. But remember, I'm going to turn that back into a fraction so that I get a, what's that, 15/4. So remember, when you're dividing, you always subtract the smaller exponent from the larger exponent and leave the answer where the larger exponent was. And y'all, on top is still what? A y to the 5th. So the y didn't have a y on the bottom to worry about. So y'all, that right there is your final answer. So your 14 is going to hit you with some x's or y's like this. So just remember, subtract them, put the answer where the larger exponent was, and then you can move on. So these logarithms sort of bring back a lot of rules that y'all played with in that other math class, as far as exponent rules and radicals and some of that fun stuff. All right, same thing again. So this is number 15. I got a ln x to the 3rd minus 5 ln 5th root of x squared. All right, so first thing we'll do is get rid of this here radical. So I'm going to bring down my ln x to the 3rd minus 5 ln x. So you do got an exponent by the x this time. So that exponent will go to the top of the fraction, and the index of the radical will go to the bottom. Now, they were nice and they brought that exponent up already, but I got this 5 here, and that 5 is going to have to get brought up. So what you would do, bring down that ln x to the 3rd minus ln x. So 5 times 2/5 equals 10/5, which equals 2. So that becomes a ln x to the 2nd. So anytime you got an exponent you got to bring up, and there's already an exponent there, you got to multiply those, okay? All right, look at this. These are being subtracted, so when I rewrite them, it's going to look like division. So the x to the 3rd is on the top because it's positive. The x to the squared will be on the bottom because it was negative. And y'all look at that. X to the 3rd over x squared leaves you 1x on the top. So at that point, you're just subtracting exponents again, okay? So hopefully that's bringing back memories. Division, we subtract exponents. Multiplication, we add them, okay? All right, so now they're going to turn up the heat on you. ln, in parentheses, x squared plus 6x plus 8 minus ln x plus 4. So nothing I can do inside those parentheses, nothing I can do inside those parentheses. So I'm going to rewrite it as a single logarithm. So I got my ln, and I know that's going to be like a big fraction. The top will be the x squared plus 6x plus 8. This part's negative, so the x plus 4 is going to the bottom. Oh, and y'all guess what? This is a rational expression. And in order to simplify a rational expression, you got to cancel out any factors on top that match any factors on the bottom. So guess what? We got to factor that top to see what makes it up. Now, I know if this is going to simplify, I got an x plus 4 on the bottom. So one of these on top better be an x plus 4 if this is going to simplify, okay? So here we go. We got an x squared. That'll be an x and an x. That 8 is positive, so both of these will be positive like the middle number. Factors of 8 that will add to get 6 are 4 and 2. 4 times 2 is 8. 4 plus 2 gives me 6. But notice, now that I got the top factored, I can now simplify this because that x plus 4 matches that x plus 4. So all that's left for my final answer is ln x plus 2. Now, y'all, let me explain my parentheses here. The reason I didn't use parentheses right here was because everything was in this fraction. So the ln applied to everything on the fraction. But once I started getting rid of my fractions, since I had an x plus 2, I had to put that in parentheses because the ln applies to both of those, okay? So you still got to worry about a little bit of factoring in this section, okay? Oh, wow, y'all, this is like the last one in this section. So here we go. We got a log parentheses x squared plus 8x plus 12 minus a log of x squared minus 36. So basically, this one's just like number 16. Can't do anything in the parentheses, so I'm going to rewrite it as a single log. X squared plus 8x plus 12 will be on the top. And in the bottom will be the x squared minus 36. Once again, I didn't need parentheses here because everything's over this one fraction. And the log is applying to the whole thing, okay? But both of these have x squared terms in them, which means both of those are probably going to factor. So let's see what happens on the top. You got an x squared, that'll be an x and an x. The last number is positive, so both factors will be positive like the middle number. Whew, let's see what I need here. I need factors of 12 that add to get 8, and that'll be what, a 6 times 2. So 6 times 2 is 12. 6 plus 2 equals 8. That bottom, that x squared minus 36, is the difference of perfect squares. You got an x and an x. Last number's negative, so you got unlike signs. And then what factors of 36 subtract and give you 0? That'll be 6 and 6. Basically, on these perfect squares, the square root of 36 is 6, so there you go. But if you notice, I got a factor that'll cancel. That x plus 6 cancels that x plus 6. So my final answer would be log x plus 2 on top divided by x minus 6. And on this one, you wouldn't need parentheses because you got the one fraction, okay? All right, y'all, so, that's 9.5, it looks like. So it looks like I think I got 9.6 and 9.7 set for Monday. That'll be the last material that's testable. Tuesday, what I'll do, I'll review for test 4, open it up. Wednesday, I'm reviewing for the final exam. And then Thursday, your final exam, okay? So test 4, you'll want to do either Tuesday or Wednesday because Thursday you want to focus on that final. All right, so I'm going to stop my share and I'll stop that.